Good afternoon to all, respected dignitaries, speakers. It's a privilege to be here on this 14th Steamtech conference. See here, today's topic for discussion is sustaining process and energy efficiency through steam system optimization. So let us discuss about what are the key drivers for process energy efficiency improvement. So first thing is the energy conservation. Now, how do we conserve the energy? Let us keep it very simple. So we should focus on improving the condensate recovery factor, which will result into your feed water temperature improvement. Also, focus on reducing the specific steam consumption of the plant and specific fuel consumption of the plant. Not only by doing this, what we are going to achieve, we are going to reduce the energy footprint or reducing the total energy consumption. So we should also not only focus on achieving the benchmark KPIs, but also we should focus on sustaining those KPIs on an ongoing basis. Now talking about the second driver, process energy improvement. By doing this, we should be able to reduce the batch time of the equipment. We should be able to improve the product quality and of course reduce the wastage or doing the right first time. And the third important driver would be the environmental impact. As we were discussing about carbon neutral, so definitely we should focus on reducing the carbon dioxide emission or NOx, or reducing the water consumption or sustaining it, and definitely, and the last but not the least, efficiently handling the effluent in the plant. So in my subsequent slides, I'll be discussing about few of the case studies of different process industries pertaining to all three key drivers. Talking about one of the multi-plant chemical group, the big giant in Gujarat, having 8 numbers of plants across Gujarat. So as we got engaged with this customer, we started with an objective of detailed energy audit of all the plants with the key priorities of safety, energy conservation, and the environment. These were the key priorities. By optimizing their steam system, we could able to achieve their enhanced safety across the plant, reliability and flexibility across their steam system, and of course achieving reducing the carbon footprint and reducing the impact on the environment. By doing this, we could able to achieve or reduce their capex by 6% and opex by 4%. Taking one of the major steam consuming equipment in chemical or API plant, that is solvent recovery unit, by doing the right solution at the equipment level, optimizing the pressure, correcting the process trap, and recovering the condensate recovery factor, it has this cascading effect of reducing 70% of their startup time, enhanced recovery of 25% of their solvent recovery, and also reducing their steam consumption by 10 to 15%. it not only helped them to save their energy, but also helped them to reduce their environmental impact by 50% reduction of their effluent load by segregation of pure and impure condensate in their plant. Taking through another success story of multi-plant formulation group in India, having 8 plants across India, and out of which 3 plants are in Gujarat. Talking about the 2 major equipments in the formulation plant, that is fluidized bed dryer and coating machine, by doing the right solution at an equipment level, which ensures the conformation to US FDA standards of manufacturing. It also helped them to get a better product quality with a better molecule composition. So one of the critical aspects here in FBD or a coating machine is maintaining the process temperature within a band of plus or minus 1 degree. So by doing the right temperature control and recovering the condensate on a efficient manner, they could able to achieve their product quality as per their US FDA norm. Taking you through one of dairy industry in Gujarat, having a production capacity of 50 lakh liters of production per day, where with the right approach of systematic approach of optimized pressure with correct trapping and condensate recovery in all their major equipments, all the pasteurizer, milk pasteurizer, ghee pasteurizer, milk pasteurizer, curd pasteurizer, and then ghee kettles, CIPs, spray dryers, we could able to achieve, not only save the energy, but also improve their product quality in ghee pasteurizer, ghee kettles, spray dryers, and milk pasteurizers. We also able to improve their condensate recovery factor by another 20%. Again, one of the major edible oil plant in Gujarat, having their production capacity of 5,000 TPD, with a right approach of systematic approach of process trap, correction of the process trap, optimized pressure, and condensate recovery at an equipment level, with all the major equipments like degum PHEs, bleachers. So it helped them to not only save their energy, but also help them to improve the quality of the oil, and with a recovery improvement of another 20% of that plant. Taking an example of one of the customer in Gujarat, having a textile customer of Gujarat, having a production capacity of 2 lakh meters of fabric per day. So we started with an approach of optimizing the pressure at their equipment level, and their correcting the correct process trap in their dyeing section. So as we know, in textile industry, recovering condensate from the dyeing section is a challenge. So proper segregation of the condensate and the cooling water help them to recover the condensate further to 20% more. Also, having an equipment level condensate recovery for each equipment. As we know, in textile industry, being a spreaded layout, so with underground condensate recovery routing, it creates a loss of not only the valuable energy of condensate, it also in terms of leakages in the condensate return line in subsequent manner. So with equipment level condensate recovery help them to not only save the energy but also improve their condensate recovery factor. Also with the contamination detection system, in the overall recovery, it helps them to recover their pure condensate to the boiler. One of the paper industry in Gujarat having a production capacity of 160 tons per day with right pressure at their drying range, group-wise pressure reduction, and right trapping in all their drying cylinder help them to achieve the better drying rate and also better product quality. It also helps them to reduce their specific steam consumption from 1.8 to 1.4 kg per kg of production. Their condensate recovery factor also improved by another 15% by efficient removing of the condensate from their each drying cylinder. So as we were discussing about all the key drivers, as I was mentioning that energy conservation, process efficiency improvement, and reducing the impact on the environment, by doing all this, we could able to achieve or we could able to reduce their energy conservation and save their energy. So, going through all the case studies, one thing is very much important. If you follow this graph at the bottom, we should start monitoring all the KPIs so that we should know, we should able to capture the variation of all the KPIs, then started improving those KPIs, and then sustaining it to the benchmark level on an ongoing basis. So this should be the focus with an higher uptime of all the steam system equipments. With this, I would like to end my session here. Thank you very much.
Thank you, Mr. Bipilji. Now I invite Mr. Karan Singh to say about his plant, ONGC.
So, good afternoon, everybody. I think we are close to 1 p.m. So, everybody waiting कि जल्दी से जल्दी session खत्म हो और हमें भूख लग रही है lunch के लिए जाएं. So, don't worry, I will try to sum up within 10 minutes. So, myself, Karan Singh, executive engineer from Hazira plant. I've been working in Hazira plant since last 7.5 years. So, first of all, I would like to thank the whole Steamtech organizing committee. We got this opportunity in front of you guys. So, I would like to represent how Hazira plant was set up and why it is happening in Hazira only, in Gujarat. So, this would be my presentation overview. I will discuss the background, the process flow, plant energy consumption and steam generation data, how many boilers we are having in Hazira plant, and what we have taken and going to take in future for the betterment in boiler industries. The first question arises in 1978 or 79 कि भारत का सबसे बड़ा गैस प्लांट लगने जा रहा है डैश 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 डैश. अब बात आ गई गुजरातियों की. दे सेड कि यार वी आर द फर्स्ट वन, हमारे यहाँ लगना चाहिए. सो द एग्जिस्टिंग प्राइम मिनिस्टर ऑफ दैट टाइम Desai, the Prime Minister of India, Morarji Desai sir, he was the finance minister and prime minister both in 77 to 79. He said, नहीं यार, Hazira में लगेगा, गुजरात में लगेगा. Although the Maharashtra government was also trying to take this plant, कि उड़ान में एक oil plant already लग चुका था, तो they planned कि यार दोनों gas and oil plant हमारे महाराष्ट्र में लगना चाहिए. तो because being a Prime Minister of India and especially the Gujarati one, ये प्लांट फिर हजीरा में लगाया गया गुजरात के अंदर. तो आई रिक्वेस्ट आप उनके लिए ताली ज़रूर बजाइए. नाउ मूविंग फॉरवर्ड, so this was the setup you seeing on screen. The Hazira plant takes the gas from two major lines, that is 36-inch line and 42-inch line. The major contribution we are getting from Tapti platform, Mukta platform and Panna platform. Recently we have added the Daman also. We are added around 6 million metric standard cubic per day gas from Daman also. So this plant was commissioned in 1985. This was still India's largest gas processing complex. We are having total capacity of 52 MMS CMD, including Daman. We have liquid condensate processing capacity of 9500, and we fed this gas to HBJ line. एक हमारी NCERT की बुक होती है, आप लोगों ने पढ़ी होगी 5 और 6 स्टैंडर्ड में, वहाँ आता है हजीरा बीजापुर जगदीशपुर line. That lines originate from Hazira plant. And this is the lifeline of whole nation in terms of gas energy. So if you see the ONGC caters about this Hazira plant caters about 80% of whole nation demand, which contributes around 30 to 35% of national demand. So we feed gas to HBG line. We have because gas we have certain value-added products, because associated content we process in our plant and make naphtha, LPG, SKO and ATF. So this is the process flow diagram of Hazira plant. We get gas from offshore. First we have gas terminal where we accumulate all the gas. Basically it's a live process. We get gas from offshore at close to 70 kg pressure. So first the gas is fed to GSU where we remove the S2S. The S2S finally goes to SRU where we produce elemental sulfur, which is completely automatic unit. Now after removal of S2S, we dehydrate the gas. We remove the water in GDU plant. Later on, this is fed to DPD, that is dew point depression. After condensing gas close to minus 40 degree, we fed to HBJ line. So as I said, we have gas as well as associated condensate. We fed the associated condensate in CFU. कई बार आपने सुना होगा देश में kerosene free में मिल रहा है, that is subsidized. The major contribution of this subsidy goes from Hazira plant. तो जो kerosene का जो हम तेल बोलते हैं, we process in CFU. Later on, the different type of process is done, like we have KRU unit, we have naphtha polishing unit, we have caustic wash unit. So we made basically VAP there. So moving forward, this is our storage capacity. We have LPG sphere, propane sphere, and we have naphtha, SKO, ATF and HF, HSD. This is recently installed. So coming to power and steam generation, for all these processing, we need huge amount of energy in terms of power as well as steam generation. So in Hazira plant, we are having 3 numbers of gas turbine. The capacity is mentioned on screen, and we have 15 megawatt of solar plant. Additionally, our 8 megawatt power plant is under execution. This is floating type. And we have 51 megawatt of CCPP power plant, which is going to commission very fast. So our plant internal consumption is around 30 to 32 megawatt. So if you see the rest of power, we wheel to another assets of ONGC. We are producing power at the cost of close to 3.5 rupees, 3.5 to 4 rupees. And we wheel this power to ONGC and we take credit around 6.5 rupees. So along with it, our main target is to run the plant as well as to wheel our power to another assets of ONGC. So this is our energy utilization in GSU, gas emitting unit, in GDU, in CFU. Majorly, we process gas and condensate, liquid. So the largest plant is GSU unit and this CFU unit. We consume close to 60%. जो energy है वो हम 60% in GSU unit and 20% in CFU unit. In terms of steam consumption, the steam is mainly consumed by the GSU plant and the CFU plant. The diagram shows we still produce LPG and which is close to 6%. In coming days, we are going to have one more LPG plant. Because of government restriction, we are allowed to have one single trains of LPG. Because क्योंकि HPG लाइन में जो हम प्रोडक्ट फीड कर रहे हैं, उनके डाउनस्ट्रीम में जो इंडस्ट्रीज हैं लाइक IOCL, HPCL, उनके पास मेजर प्लांट्स हैं. So हमें एक restriction है, तो हम we can install only one single unit of LPG. So moving forward, we have to meet this energy demand. We have total 8 numbers of boiler. That is HRSG 1, 2, 3, 4 KTI, 2 ISC boilers, and Thermax and IBL boiler. So we have total steam generation capacity of close to 600 ton per hour. Moving forward, this is typical diagram of our cogeneration. We utilize the gas turbine exhaust in HRSGs. Our major contribution, if you see this slide, our major steam contribution close to 350 or 400 is from HRSGs. So we have 3 gas turbines. So this is typical diagram, one of the GTs and HRSGs. We have diverted damper. Basically, it's divert the flue gas to boiler. Then we have gelatin damper. It's a protection of GD damper. Then we have, because we run HRSG in 2 mode. One is gas turbine mode, GT mode, and another is GT plus S mode. That is supplementary firing. And the third one is, वो हम बहुत rarely use करते हैं, that is FD mode. In case of urgency, if you see, अगर कोई like दूसरे boiler का tripping हुआ या मेरा annual shutdown में है, in that case we operate in FD mode. So 90% of the time boilers run, especially HRSG runs in GT mode. So then we have this diverted damper, then we have gelatin damper. This goes to HP drum first, then flue gas goes through LP drum, then we have economizer, and later on we try to extract the energy in makeup heater. This is the DM water which is fed to deaerator, and finally we emit this in the environment through chimney. We try to maintain the temperature close to 140 to 150 degree. So for the better analysis of boiler fed parameter, we have SWAS system there, and also we have stack monitoring system also. So in HRSGs, we do shutdown every 2 years because we sometimes get the extension from boiler office. For that purpose, we shave around 20 days of shutdown. But through this SWAS, because ये SWAS का होना बहुत mandatory है अगर आप HRSG में extension चाहते हैं. Because boiler inspector जो है वो certify करते हैं. He personally visit the boiler house and do all the protection test. Then he ensure कि नहीं आप extension ले सकते हो, but within 2 years आपको दोबारा से shutdown करना पड़ेगा. So HRSG अगर industries में है और SWAS panel है, तो you can easily save your shutdown time. Moving forward, we have if I share some financial data for ONGC Hazira plant, we are generating around 24,000 crores a year in terms of revenue. if I talk about profit, we are close to 7,500 to 8,000. 24,000 हम revenue generate करते हैं, 8,000 करोड़ हमारा profit है. So this we basically try to save energy as much as possible. We have recently achieved some financial data, some in terms of finance. We reduced our CSU back pressure. One of the speaker was sharing कि आप अगर 1 kg बैक प्रेशर रिड्यूस करते हैं तो आपका इनलेट में 6 kg का इम्पैक्ट आता है. So earlier it was 1.5 kg in our CSU vessel, and we bring down to 0.3 kg, which is very negligible. So this after doing this, we basically achieved 10% hike in return condensate. We have continuously trying to maintain the steam trap system. Moving forward, I think it's one of the beautiful event which is going happen in boiler industry right now. So I would like to thank Director of Boilers for this wonderful opportunity, and I would like to thank our ED plant manager sir for this sending here and to represent ONGC at this level. I would like to thank our plant head maintenance sir, and also our cogen in charge, basically Varapatre sir. So we all are gathered for one simple cause. We all want to save energy. We all want to save fuel, because as far as boiler is concerned, we all are as a one family. If we want to grow together, we have to work together. We have to walk together. We have to learn together. For this purpose, I want to share few lines written by me. I think it's give you समथिंग ऑफ, कहते हैं कि गूज बम्प आपको मिलेगा. तो हमें आज सब पूरी बॉयल इंडस्ट्रीज इरेस्पेक्टिव ऑफ द इंडस्ट्री वेदर इट्स इन पब्लिक सेक्टर और गवर्नमेंट सेक्टर, आई वांट टू शेयर फ्यू लाइंस कि तुम चलो हम चलें फिर चलेगा ये जहां, तुम चलो हम चलें फिर चलेगा ये जहां, तुम बढ़ो हम बढ़ें फिर बढ़ेगा ये जहां, तुम चलो हम चलें फिर चलेगा ये जहां, तुम बढ़ो हम बढ़ें फिर बढ़ेगा ये जहां, और चलते चलते रुकना नहीं है, रुक रुक कर चलना नहीं है, चलते चलते रुकना नहीं है, रुक रुक कर चलना नहीं है, तुम थके हम थके मानो थक गया रास्ता, तुम चलो हम चले फिर चले गए जहां. कि नन्हे नन्हे से यहाँ तारे भी बहुत हैं, अगर ना चमके तो अंधियारे भी बहुत हैं. देखिए, एवरी इंडस्ट्री हैज़ टू वर्क इन देयर एनर्जी ऑप्टिमाइजेशन. फॉर दैट पर्सपेक्टिव आई राइट कि नन्हे नन्हे से यहाँ तारे भी बहुत हैं, अगर ना चमके तो अंधियारे भी बहुत हैं, और टूटा एक तारा टूटे दो तारे, टूटा एक तारा टूटे दो तारे, मानो खाली हो गया आसमां, तुम चलो हम चले फिर चले गए जहां. यही चीज एनकरेज करती है एट लास्ट कि द डायरेक्टर ऑफ बॉयलर सर वो शेयरिंग की एक्सीडेंट होते हैं, ठीक है, दैट कैन बी अवॉइडेड, बट फिर भी हो जाता है. हमें उनसे कुछ लर्न करने की जरूरत है सो दैट वो रिपीट ना हो. उस प्लांट के लिए नहीं, हमें बाकी बॉयलर इंडस्ट्रीज के लिए इंश्योर करना है कि वो, आई थिंक मैं तो रिक्वेस्ट करना चाहूँगा कि उसका एक इंसिडेंट रिपोर्ट बनना चाहिए, दैट शुड बी पब्लिश्ड ऑन दी बॉयलर का जो वेबसाइट है, सो दैट एवरीबडी गेट इनसाइट कि यार ये चीज़ वहाँ हुआ था. एंड पीपल में अदरवाइज क्या होता है, यहाँ पे यूट्यूब पे न्यूज़ आती है फिर पता चलता है, तो इसकी एक रिपोर्ट बन के शेयर होना चाहिए. तो लास्ट में कि लास्ट में एक्सीडेंट वाला था, सॉरी, वो बहुत, दैट वाज वेरी नाइस मैसेज कि अतीत से हम क्यों डरें, बस उसका चिंतन करें. अतीत से हम क्यों डरें, बस उसका चिंतन करें, भविष्य हो उज्जवल ऐसा मनन करें. अतीत से हम क्यों डरें, बस उसका चिंतन करें, भविष्य हो उज्जवल बस ऐसा मनन करें, और एक साथ जुड़े और खड़े होके देखो एक जरा, तुम चलो हम चले फिर चलेगा जहां. So thank you so much, thanks a lot for giving this wonderful opportunity. So thank you so much.
Thank you, Karan Singh. Now we have nice presentation by different speaker. First of all, Mr. Tandel. Usually he is a always there in this site of the seminar. He talked about the cogeneration plant and costing of the cogeneration plant. Mr. Deepak Chandarana from TCR, he talked about the energy audit and metallurgy problem of the boilers. Then Mr. Bipin Paul from Forbes, they are the steam people. So they are excellent for the distribution of steam. And lastly, from ONGC, Mr. Karan Singh, he shows his hunger for the consumption of the energy, steam. Now we are at the point, we are also hungry. Lunch is ready. Now there is a two choice. For knowledge hungry, you are hunger for the knowledge or food. Choice is yours. So I request to ask the questions to all the colleagues. One person from the cogeneration plant, one person from the steam distribution, second is the problem of the boilers of the metallurgical problems, and one is the user of the steam, that is ONGC. So you have more choice to ask the questions. I think so, everybody is hungry. Okay.
Hello. Sir, this question for Deepak sir. Regarding the metallurgy, you shown in the slides that am I audible?
Yeah. Please.
So, the metallography, the process which we use for the furnace tubes and reformer tubes, so is there any fast process or any kind of better technology? Is there any kind of that we can presume the life cycle of the tube perfectly? So nowadays we use the SEM techniques for calculating the microstructures, grain structures and all that things. But if there is any kind of new technique that such that we can go for more precise in terms of calculating the time. Suppose initial days we perform the metallography after 2 years. So can we predict that okay, now we have go for revamping the next 5 years or next 7 years? Is there any kind of this technique?
Yeah, actually, it's a good question. Basically, if you look at our website, TCR Advance, you would find all technologies and all services which we are rendering, including advanced entity in metallography. We have SEM EDS machine also. Now, your question is very broad, actually. I think we need to discuss it in person because, as you said that, you want to rather save the time as well. Rather, how we can estimate the life of that particular system or component. So that is, we have to discuss in length because I think, because it also, once we do the any testing or inspection, we do the condition assessment. If somebody wants that we want the life assessment, we give that the life assessment. So it all depends upon your requirement. We can do it.
Good afternoon, everyone. My question is to Mr. Jignesh Tandel, sir. Sir, you talked of the various cogen options available, like cogen, microgen, power generation, and captive cogen. So, keeping the total energy generation of all the options same, total power and steam, whatever we are generating, if the generation is same, how will you grade and rate the efficiency of these options?
See, basically, am I audible?
Yes, yes.
Yeah. So basically, we talked about 4 systems. Okay, the first was the microgen. Now the microgen system is for your existing systems or existing steam generating system what you have and your process requirement. So here you cannot graded as per your requirement. So this the power generations will not match for all the 4 systems. But in terms of efficiency, if you say, so I think the microgen will be the most efficient system, because in this system you will not add energy or extra fuel to the system to generate power. Here your power will be a complete byproduct. In terms of quantity of power generation, it will be the minimum, because you have an existing system where you are installing this. So it will be a minimum power generation, but it will be the most efficient system.
Okay.
The second cogen will be the second most efficient, where you have higher pressure and high steam temperatures for generating power. And likewise, the extraction condensing system is the third efficient, and condensing is the last. So that
Okay,
way
thank
you
you.
can grade.
In this, now people are doing the where if you are having 100% condensing in the existing system, then you have to switch over to the back pressure. That is one more concept is coming to utilize the maximum thing in-house, whatever you are having a foundation, etc., keeping the same, and you are adding the back pressure, converting condensing 100% condensing or extraction condensing to the extraction back pressure. So that will be added economic or sustainable to your unit. Thank you.
सर अभी मेरा क्वेश्चन है, अभी हमारा प्रोसेस प्लांट है, बैक प्रेशर टर्बाइन है, अगर प्रोसेस में रिक्वायरमेंट कम हो गई, जो वेस्ट जा रहा है स्टीम, तो क्या करना चाहिए? लोड कम करना चाहिए इलेक्ट्रिक के प्रोसेस स्टीम के वेंट करना चाहिए, वेस्ट करना चाहिए?
नहीं, वेंट करोगे मतलब आप एनर्जी डाल रहे हो एटमॉस्फेयर में, आप
हाँ।
सिस्टम में, तो बेस्ट थिंग इज यू शेयर द लोड.
नहीं, लोड का रिक्वायरमेंट है, प्रोसेस स्टीम का नहीं है. तो
लोड का
इलेक्ट्रिक लोड का रिक्वायरमेंट है, प्रोसेस का नहीं है. तो ग्रिड में लेना अच्छा है कि टर्बाइन चलाना अच्छा है?
नहीं, ग्रिड में सी व्हाट इज योर ग्रिड कॉस्ट एंड व्हाट इज योर फ्यूल कॉस्ट. बेसिकली
Both are same.
सी इट विल बोथ आर सेम, और आपका सिस्टम है तो फिर यू यूज योर सिस्टम.
नहीं, अगर प्रोसेस यूज कर रहे हैं तो
हाँ।
कॉस्ट कम जा रहा है, जनरेशन कॉस्ट.
बराबर है.
अगर वेंट कर रहे हैं तो वही कॉस्ट आ रहा है.
नहीं, वेंट करोगे तो आपका कॉस्ट हमेशा बढ़ेगा.
हाँ, वही होता है. अगर हम प्रोसेस में यूज करते हैं तो जनरेशन कॉस्ट कम होता है. अगर नहीं करेंगे, वेस्ट करेंगे,
हाँ,
तो वही ग्रेड का कॉस्ट ही आता है.
नहीं, उसमें क्या होता है, देखिए डिपेंड करता है आपकी कैपेसिटी के हिसाब से, प्लांट की कैपेसिटी के हिसाब से. लेकिन जब आप वेंट करते हो, मतलब आप कंडेंसेट भी रिकवर नहीं कर रहे हो, ये आप पूरा एटमॉस्फेयर में डाल रहे हो, तो योर हाँ, तो वो ग्रेड से भी ज़्यादा आएगा.
सर एक क्वेश्चन पोल साहब का, अगर वेंट हो रहा है मेरा, वेस्ट हो रहा है, उसको रिकवरी करने का कोई सिस्टम है? कंडेंस का रीयूज करने का?
कंडेंसेट
सर क्वेश्चन में पूछ लो, यहाँ पूछ लो सर.
नहीं,
नहीं, अगर वेस्ट जा रहा है जो भी स्टीम, प्रोसेस में रिक्वायरमेंट अनइवन है, अगर कभी कम हो गया और वेंट हो रहा है, उसको मुझे रिकवर करना है, उसके लिए कोई सिस्टम होगा ना?
सर बेसिकली अभी वो सिस्टम नहीं है. इट विल डिपेंड ऑन योर प्लांट के कंडीशंस. यू कैन हैव अ सिस्टम.
नहीं, अगर वेंट हो रहा है तो उसको कंडेंस करके रीयूज कर सकता हूँ, वही पता.
दैट इज व्हाट आई एम आंसरिंग. आपके क्वेश्चन का मैं आंसर कर रहा हूँ. यू हैव एन एक्सट्रैक्शन कंडेंसिंग सिस्टम, राइट? आपके पास
अभी बैक प्रेशर.
ओके, 100% बैक प्रेशर है, तो देन यू हैव टू पुट एन एक्सट्रैक्शन कंडेंसिंग. यार एक एक्स्ट्रा हीट रिकवरी सिस्टम आता है,
हाँ.
जिसमें कंडेंसर ऐड करो, एंड व्हेन यू हैव एक्सेस इलेक्ट्रिकल लोड, तो स्टीम लोड कम है पर आपका इलेक्ट्रिकल लोड ज़्यादा है, तो ये आप लीड करके यू पास इट थ्रू अ कंडेंसर. एक डम कंडेंसर आता है,
हाँ, वही.
तो यू कैन यूज इट, बट वो भी आपको कॉस्टली पड़ेगा. आज के फ्यूल प्राइसेस, आज के
अच्छा,
सिनेरियो.
एक डम कंडेंसर अगर डालते हैं तो पेबैक टाइम मैक्सिमम कितना होना चाहिए?
सर वो मैं वही बोलना चाहता हूँ आपको कि आज के कंडीशन में फ्यूल के प्राइसेस हाई है, इसलिए एक डम कंडेंसर आपको वायबल नहीं होगा. द पेबैक्स विल बी वेरी.
दूसरा पोल साहब एक क्वेश्चन है, अगर हमारा पूरा पावर प्लांट में प्रोसेस स्टीम भी जाता है, हर जगह पे ट्रैप जो काम नहीं कर रहा है, कई जगह पे ट्रैप काम नहीं कर रहा है, स्टीम निकल रहा है, और ट्रैप में से जो कंडेंसेट निकल रहा है उसको रिकवर करके रीयूज करना है, तो उसके लिए कौन सा ट्रैप अच्छा है?
हेलो. वर्किंग यस। तो सबसे पहले जो आप बात कर रहे थे कि जो मेन लाइन ट्रैप्स है, तो मेन लाइन ट्रैप्स के लिए सबसे जो प्रिंसिपली एग्रीड है दैट इज़ अ थर्मोडायनेमिक ट्रैप। थर्मोडायनेमिक ट्रैप ही होना चाहिए मेन लाइन ट्रैपिंग के लिए। और आपने बताया कि अगर मेन लाइन ट्रैप में अगर स्टीम लीक हो रहा है तो सबसे पहले तो आप
वो तो ट्रैप रिप्लेस कर देंगे।
करेक्ट। सो थर्मोडायनेमिक ट्रैप का कंडेंसेट भी आप रिकवर कर सकते हैं, बट ओनली थिंग इज ये इंश्योर करना पड़ेगा कि आपका जो थर्मोडायनेमिक ट्रैप का जो कंडेंसेट है, बिकॉज वो नॉर्मली क्या रहता है मेन लाइन में जो डिस्ट्रीब्यूशन लाइन का जो ट्रैप है, we recommend to have a, depending on the line routing, we recommend as a thumb rule, we recommend to have a main line trap in every 25 to 30 meters of distance. Okay? So उस हिसाब से आपको वो लाइन को आपको लेके जाना पड़ेगा। and there is one more option that we can have a small recovery pump also to recover those condensate from the main line recovery.
Okay. आप कहाँ से है सर? Which company?
सोलारिस ब्रांड के।
अच्छा, इसमें दो चीज़ है। एक चीज़ ये है कि जैसे आपने बताया कि प्रोसेस में स्टीम डिमांड नहीं है और इलेक्ट्रिक
प्रोसेस में नहीं है ऐसा नहीं, अनइवन रहता है।
अनइवन रहता है तो बट आपका इलेक्ट्रिकल डिमांड तो कांस्टेंट रहता है।
इलेक्ट्रिक रहता
तो वो केस में स्टीम को वेस्टेज करके इलेक्ट्रिसिटी जनरेट करे कि ग्रिड से ले,
यही पूछ रहा हूँ। अगर वेस्ट हो रहा है उसको भी रिकवर करने के लिए कोई
या फंडामेंटली कोई भी एनर्जी ऑडिट होता है ना, उसमें क्या है कि इलेक्ट्रिकल एनर्जी लॉस है ना, उससे बहुत गुना ज़्यादा थर्मल एनर्जी लॉस रहता है। तो थर्मल एनर्जी, दूसरा क्या है कि इट इज़ कंसिडर्ड टू बी ए क्राइम इन इंडिया। जैसे कि गैस टर्बाइन है, कंबाइन साइकिल की जगह पे आप ओपन साइकिल चलाते हो, इट्स ए क्राइम बिकॉज गैस कॉस्ट इज़ वेरी हाई। तो ओपन साइकिल पे हम लोग यहाँ पे नॉर्मली अवॉइड करते हैं। वी ऑलवेज ऑपरेट अवर गैस टर्बाइन इन कंबाइन साइकिल मोड टू एक्सट्रैक्ट द एनर्जी टू गेट द एफिशिएंसी ऑफ 35-40%। तो वैसे देखा जाए तो ऐसा नहीं करना चाहिए, स्टीम आपको स्टीम में नहीं डालना चाहिए।
एक्चुअली क्या है, शॉर्ट टर्म के लिए तो वेंट करते हैं, बाकी लॉन्ग टर्म के लिए तो पावर रिड्यूस कर देंगे।
हाँ ठीक है, ओके, दैट इज द बेस्ट आइडिया।
अगर प्रोसेस में डिस्टर्ब होगा तो शॉर्ट टाइम के लिए वेंटिंग होता है तो वो तो करना पड़ेगा।
हाँ ठीक,
क्योंकि फ्रिक्वेंटली चेंज नहीं करते लोड। और दूसरा सर, ये आपने जो लाइव स्ट्रीम का बताया, ऐसे जो प्रोसेस में 5 kg वाला स्ट्रीम जा रहा है, जनरल प्रैक्टिस ऐसी है, ट्रैप तो काम नहीं करता, ऑडिट करते हैं हम, वही वो जो कंडेंसेट होता है, पानी निकलता कंडेंस होके, उसको भी रिकवर करना है लो प्रेशर वाला। 5 kg प्रेशर है, 200 टेम्परेचर।
हाँ कर सकते हैं ना,
बट उसके लिए वही ट्रैप यूज होगा।
नहीं, आप कौन सा प्रोसेस की बात कर रहे हैं? कौन सा प्रोसेस है?
प्रोसेस प्लांट है, अभी 5 kg प्रेशर वाला है, 200 टेम्परेचर वाला प्रोसेस टीम है।
आपका कौन सा प्लांट, आप कौन सा?
ब्रोमिन प्लांट है। हाँ, ब्रोमिन प्रोसेस प्लांट।
ओके,
ब्रोमिन प्रोडक्शन ब्रोमिन का है।
ओके,
को जनरेशन प्लांट है।
कोजन, हाँ वही तो
रिक्वायरमेंट है सर, उसका डिजाइन है, डिजाइन
तो
5 का है।
सुपर हीटेड स्टीम यूज कर रहे हो आप? 5 kg में 200 डिग्री टेम्परेचर।
सर कंडेंस होता है, ट्रैप में से जो कंडेंस निकलता है उसको मुझे रिकवर करना है, उसके लिए सिस्टम बनाना है जो वेस्ट जा रहा है अभी।
अच्छा, तो वो तो आप कर सकते हैं ना थ्रू कंडेंसर।
उसके लिए ट्रैप कौन सा यूज चाहिए?
आप नहीं, ट्रैप से आप कंडेंसेट रिकवर नहीं कर सकते, उसके लिए आपको सेपरेट पंप के थ्रू ही कंडेंसेट रिकवर करना पड़ेगा।
सर ये 4 मार्शल ने सिस्टम दिया इसलिए पूछ रहा था, दूसरे प्लांट में।
नाउ प्लीज सिट डाउन प्लीज, अभी सेशन पूरा नहीं हुआ है, प्लीज।
My question to Karan Singh, if possible, kindly explain the Thermex boiler incidents happens at ONGC so that everybody get idea how we can avoid such incidents in our factory. Please.
One thing that was not, again boiler is very common name, so everybody mentioned कुछ भी fail होता है जैसे कि boiler हुआ. That was not purely boiler incident. There was because we run Thermex boiler on FD mode. तो उसमें जो हमारा फ्लू गैस डक्ट था that was weld failure. Simply जो फ्लू गैस का डक्ट फेलियर हुआ था, जो हमारा just after the boiler goes to economizer, वो वाला डक्ट फेलियर हुआ था. That is non-IBR part. So that was not, I think that was part of boiler, but not actually boiler. So non-IBR part में welding joint rivet failure हुआ था. Somehow because the boiler was very old and we did all the job within 5 to 6 months. हमने पूरा duct work change करा दिया था. तो IBR part still intact and the boiler still one of the best boiler in Hazira plant. So simple sir, जो weld joint fail हुआ था हमने उस duct को change कर दिया. Thank you.
Is there any questions? Yes.
नमस्कार सभी को. मेरा कोई टेक्निकल सवाल नहीं है, बहुत ही नॉर्मल सा बेसिक सा सवाल है जो मैंने पर्सनली आज यहाँ फील किया है. आज यहाँ आने के बाद में मैंने ये नोटिस किया है, 3 साल से गुजरात में काम कर रहा हूँ. गुजराती लोगों का काफ़ी कनेक्टिविटी बहुत अच्छा है अपने लैंग्वेज को लेके, जो मैं बहुत ज़्यादा अप्रिशिएट करता हूँ. हर जगह पे हमें गुजराती लोग अच्छे से बात करते हुए समझ में आते हैं. पर पर्सनली मुझे आज फील हुआ कि मैं डायरेक्टर ऑफ बोर्ड को सुनना चाहता था, समझना चाहता था, पर मैं आज समझ नहीं पाया उनको, क्योंकि वो प्रॉपर गुजराती में बात करके गए. तो क्योंकि मैं उनको पहली बार आज देखा हूँ और कहीं ना कहीं मेरे लिए इंस्पिरेशन भी है वो, क्योंकि मैं उनको देख के आगे सीखना चाहता हूँ, उनके नक्शे कदम पे चलना चाहता हूँ, पर मैं उनको समझ नहीं पाया. तो मैं क्या करूँ? इंग्लिश में समझ में आती है, हिंदी भी आती है, गुजराती भी कहीं ना कहीं राजस्थान से वो तो आती है.
Please, I request to meet me at my lunch. I will explain what D.S. Patel has told.
That is not a problem.
In your own language.
Yeah, that is not a problem, sir. गुजराती मुझे बहुत अच्छा लगता है जब सब लोग लोकल लैंग्वेज में बात करते हैं. नॉर्मली मैं राजस्थान से हूँ, वहाँ पे हम राजस्थानी में इतना बात नहीं करते हैं जितना गुजराती में हर एक बड़ी ऑर्गेनाइजेशन से लेके छोटी जगह पे सब लोग बात करते हैं. पर आज थोड़ा सा मुझे गैप दिखा. मुझे जैसे करण सर ने बात की तो कहीं ना कहीं कनेक्टिविटी मुझे फील हुई डायरेक्ट टू डायरेक्ट, पर थोड़ा सा गुजराती में समझ नहीं आया मुझे.
ये मैन्युफैक्चरिंग डिफेक्ट है गुजरात में. इनका मैन्युफैक्चरिंग डिफेक्ट. नरेंद्र मोदी भी गुजराती में बात करते हैं कभी कभी.
नहीं वो
होता है, पर वी विल एक्सप्लेन यू इन हिंदी और वॉट एवर लैंग्वेज.
ओके,
डोंट वरी.
थैंक यू सो मच सर, थैंक यू सो मच.
It was, hello.
जी सर.
Yeah, actually, yeah, right. You know, you couldn't get it. What Director Boiler Operation said.
जी सर.
Basically, he's a brief narration on boiler industry. You know,
Okay.
how the challenges are there and what to do. Actually, very importantly, a salient point of that particular presentation was that, he said that, safety, because nowadays, technology is growing at very fast pace. And tomorrow we would be using hydrogen as a fuel in the boiler. So there are a lot of safety factors. Safety is always the priority. See, safety is a priority. The second is the production. So in that way, he said that, this government of Gujarat Boiler Inspectorate Department have started one initiative that, they goes to rather a small boiler industry. He said that, you must have worked with the industry where you were part of the team, where there are a lot of people, those who are in the boiler operations, and they are owner of that particular plant, but they are operating the boiler themselves. So in that way, the training they have started in the cluster, and they give some rather knowledge and information on how and what can be done to rather protect the safety of the human being and as well as the equipment and maintain the asset integrity. That was the, nutshell of his talk. I think it's clear now.
Yes, sir. Thank you so much, sir. Thank you.
ओके.
जैसे कि करण सिंह जी ने बोला कि कोई भी इंडस्ट्री में अगर बॉयलर में कोई एक्सीडेंट होता है तो एक प्लेटफॉर्म होना चाहिए या वेबसाइट होनी चाहिए कि जहाँ पे वो एक्सीडेंट का इन्वेस्टिगेशन, उसके करेक्टिव एक्शंस क्या हैं वो हम सबको मालूम पड़े. और मैं भी एक सेफ्टी प्रोफेशनल हूँ, तो मैं आप लोग से जानना चाहता हूँ कि हमारे बॉयलर के जो बॉयलर चलाते हैं, जो वहाँ पे मास्टर है या जो भी बॉयलर का स्टाफ है या इंजीनियर्स है, तो उसके लिए कोई एक बेसिक पावर पॉइंट प्रेजेंटेशन या वीडियोस का कोई ट्रेनिंग प्रोग्राम्स कोई प्लेटफॉर्म पे मिल सकेगा?
हेलो, आप कौन सी इंडस्ट्री से?
टेक्सटाइल है.
टेक्सटाइल में से। जो बॉयलर ऑफिस है वो सभी ट्रेनिंग प्रोग्राम रन करते हैं, चालू बॉयलर पे भी ट्रेनिंग देते हैं, वो भी प्रोग्राम चालू ही है। तो उसमें कई आपको जो ज्वाइंट होना है कि आपको कोई कैंडिडेट भेजना है तो हमारा बॉयलर ऑफिस का संपर्क करना।
ओके, तो वो वहाँ से हमको ट्रेनिंग स्लाइड्स मिलेगी कि वहाँ उनके
नहीं,
यहाँ पे
रेगुलरली बॉयलर इंस्पेक्टर और डायरेक्टर आपके वहाँ पर आ जाएंगे, आपको फिजिकली और प्रैक्टिकली ट्रेनिंग देंगे।
थैंक यू।
Any question? Okay, thank you very much. Thank you to all the speakers and thank you for all the learned
We will come
audience.
back. We will come back from the lunch at sharp 2:15. So please cooperate. As we are going to start our second business session that is based on the theme of boilers of the future using green technologies. I would like to invite our dignitaries to the stage one by one. Shri H.K. Panchal, retired director of boilers, please come on the stage. I would like to invite Mr. Anas Sheikh to give him memento and bouquet. Shri Subhashish Das, Business Development Head, Forbes Marshall Limited. I would like to invite Mr. Chirag Panchal to give him memento and bouquet. Shri Subhash Das is Business Development Head at Forbes Marshall for Project and OEM Market Segment. He is associated with Forbes Marshall for over 18 years now. Shri J.B. Suhag, Consultant, TSJ Techno Power, Ahmedabad. I would like to invite Jayesh Joshi to welcome him with the memento and bouquet. Mr. J.B. Suhag is a mechanical engineer and first-class boiler proficiency engineer from Gujarat Boiler Boards. Shri Dinanath Akela, IBR competent person, BOE trainer and certified energy manager. I would like to invite Mr. Rakesh Nadia to welcome him with the memento and bouquet. Shri Dinanath Akela is competent person of inspection and certification of boiler, Central Boiler Board, New Delhi. Shri S. Manjunath, General Manager, Sri Sai Power and Equipment Private Limited. I would like to invite Mr. Anas Sheikh to welcome him with the memento and bouquet. Shri S. Manjunath is a BE Chemical Engineering boiler operation engineer having 30 plus years of experience. Now I would like to hand over mic to the Shri H.K. Panchal for the session.
Hello, thank you for handling the session 2. This session 2 is the post-lunch session. So I request all of you to remain present mentally, not physically. This, our session 2 theme is boiler of futures using green technology. What is green technology? Green technology describes the use of technology and science to reduce human impact on natural environment. Green technology include a wide area of scientific research, including energy, atmospheric science, agriculture, and material science. Many green technology aim to reduce the emission of carbon dioxide and other greenhouse gases in order to prevent the climate change. Examples of green technology are emission treatment, convert waste to energy, recycling and waste management, biofuels, wastewater treatment, solar energy, wave and tidal energy, wind technology, eco-vehicles, smart building, and vertical gardens and farms. So we have to, this session goes for especially for green fuels. And which green fuels are there? Green fuels are biomass, geothermal energy, wind power, solar, hydro, biofuel. Green fuels are that who are in nature carbon neutral or even carbon free. Also, green fuels are biodiesel, ethanol, hydrogen, natural gas, etc. So now I request the first speaker, Sri Subhash Das, Business Development Head, Forbes and Marshall, to deliver his presentation.